وعدتكم في the second term grade 2. I hope you enjoy. Thank you.
Non-negative and negative integer powers in R. We will remember that if I write the power 6 of the power 2, it's equal 6 times 6. It means that we multiply the number 6 by itself 2 times, which equals 36. And if I see this, it means that I know that A is the base and N is the power. And I know that from the previous year, any number of the power 0 equal 1 except the 0. If I write 0 of the power 0 is undefined. So any number except the 0 of the power 0 equal 1. And if I take a negative number like negative 3 of the power 2, it means multiply negative 3 by itself 2 times. Negative 3 times negative 3, which is 9. This means that if I have a negative number of the power even number, then the negative will disappear. Like here. I have here negative and here no negative. Okay? If I have a negative 3 of the power 3, it means multiply negative 3 by itself 3 times. Negative 3 times negative 3 times negative 3, which is negative 27. Because negative times negative, positive times negative equal negative. So if I take a negative number of the power odd number, then the negative will be with me. Okay, we put the negative out the power. And if I have the power is the negative number, like here I have 3 of the power negative 2, it means that we take the inverse of number 3, the multiplicative inverse of number 3, it is third of the power 2, which is 1 over 9. Okay, and here the same, the multiplicative inverse of the number 3 over 4, it's 4 over 3, and the negative will change to positive. Okay, and if I multiply two numbers with the power 2 of the power 2 times 2 of the power 4 equal 2 of the power 6. How? If the bases are the same, we put the base and add the power. 2 plus 4 equals 6. In division, division is the inverse of the multiplication. Here I add the power, but here we subtract the power. I put the base which is 2, and 6 minus 3 is 3. Okay, and here I have 3 of the power 4 of all of the power 2, which mean we multiply the 2 and the 4, 2 multiply 4, which is 3 of the power 8. So any number of power, all of the power, we multiply the powers. Here I have a note that here it's a fraction number, so I know that B will must be not equal 0, and here its inverse must be not equal 0. So both A and B not equal 0. Okay, let's see an example. Simple 1. Simplify to the simplest form this form. I have here, we can solve the numerator first. I have here the base the same, and we add the power. It's 4 over 2x plus x. It's 3x over 4 of the power x. And here division. So I put the 4 and 3x minus x, which is 2x. Or simply you can simplify 4 of the power x with 4 of the power x together. Okay? I have a new type of the equations called the exponential equations. In this equation, I have the unknown, or the value is a power in the power. Like what? Like here, I have 5 of the power x minus 2 equal 25. It's an equation, but x in the power. And here, the same. I have here x in the power in the equation. Okay, let's see an example. Here, I have 3 of the power x equal 26. How to find the value of x? We transform the 27 into the shape of the power. So I write 3 of the power x is the same, and 27, it's 3 times 3 times 3, which is 3 of the power 3. So I have the base equal the base. So the power will equal the power. X equals 3. Another one, 2 of the power x plus 2. I will translate this 16 to the base 2. Okay? It's like 2 of the power x plus 2, the same, and 16, it's 2 times 2 times 2 times 2, which is 2 of the power 4. So from here, I have the bases are the same, so x plus 2 will be 4. And by adding negative 2 for the both sides, I get x equal 2. So in this type, all the bases are the same. So I can say that if the bases are the same, the power should be the same. Okay, and we can simply find the solution. But if the power are the same, what can we do? Like here, I have a of the power n equal b of the power n. So like here, I have the power 3, and the base are a equals 7. A equals 7. From here, I can say, what is the number of the power 3 equals 7 of the power 3? We can say that a equals 7. And here, a of the power 2 equals 7 of the power 2. The same, I can say that a equals 7. A equal positive or negative 7. How? Because there is a difference between this one and this one. I have here the power is odd number, and here even number. Is it make a difference? Yes, it make a big difference, because here, if the power is odd number, then the base equal the base. And if the power is even number, so I get the base equal positive or negative 8, because I know that if the number here negative 7 of the power 2, it will equal 7 of the power 2, because the power is even, as we remembered. And if the power are the same, but the base is not the same, so the power should be equal 0. The bases are not the same, then the power equals 0 to satisfy the equation. I should to make the both sides equal. From here, if I put the n equal 0, I get 5 of the power 0, which is 1. And the other side, 7 of the power 0, will equal 1. So the both sides are equal. Let's see an example. Here, I have 4 of the power x plus 1 equal 1 over 64. Can I make the bases are the same? Let's try. 4 of the power x plus 1, I will leave it as it, because I don't know how to change it. I take the right hand side and try to make it base the same. I have here 1 over 64, I can write 1 over 4 of the power 3, right? Because 1 of the power 3 equal 1 and 4 of the power 3 equal 64. Okay, I have here 1 over 4, but I needed 4. So I can put the multiplicative inverse of 1 over 4, which is 4. But the power will change because I change the number 4 of the power negative 3. I have here the bases are the same, so I can say x plus 1 equal negative 3. By adding negative 1 for the both side, x will be negative 4, and the solution set is negative 4. Another one, 3 of the power absolute value x equal 81. Let's see. I have here the base 3. Can I change this number to the base 3? Yes, because 81 is 3 of the power 4. So from here, from the first method, I can say the absolute value of the x equal 4. And absolute value means that x has two values, positive or negative 4. So the solution set will be 4 and negative 4. Operations on integer powers. I know before that if I have many operations and the same equation or problem, I have ordered to make it. If I see, I will solve the branches first and then the power, and after that multiplication and division. But if I have the both, I will make according to the order which came first from the left to the right, and the same will be for the addition and subtraction, which came after the multiplication and division. Let's see an example and understand. I have here 20 divided by parentheses 12 minus 2 times 3 of the power 2 minus 2. Here I will start with the parentheses because it's in the top. So 20 is the same divided 12 minus 2, which is 10, times 3 of the power 2 minus 2. Here the second one will be the power. So 20 divided by 10 times 3 of the power 2 will be 9 minus 2. And here I have division, multiplication, subtraction. So I will make division and multiplication. Which one came first? Division. So 12 divided by 10, which is 2, times 9 minus 2. Multiplication and subtraction. Yes, multiplication. 2 times 9, which is 18, minus 2. And then 18 minus 2 will be 16. And we solve the equation. Is that question? Okay. Here I have in this question, I need to simplify this one to the simplest form. Let's try. I have here a division in the numerator. Let's finish the numerator first. The square root of 8 and here the square root of 2. Can I change square root of 8 to square root of 2? Yes. Focus with me. I made square root of 8 as 2 square root of 2. Yes? Yes, right. Of the power 3 divided by 2 square root of 2 of the power 3, the same. And in here I have square root of 2 plus 2 of the power 2. I can simplify. Yes, square root of 2 of the power 2, which is 2, plus 2 times square root of 2 times 2, which is 4 square root of 2, and 2 of the power 2 will be 4. minus 4 of square root of 2. Okay, in the denominator I have square root of 2, square root of 2, but first I will take the 2 outside the parentheses. So 2 of the power 3 out, because I have here power 3 of the 2 also, and the square root of 2 of the power 3 divided by 2, square root of the square root of 2 of the power 3, and here I have 2 plus 4, it's 6, and 4 square root of 2 minus 4 square root of 2 will be simple, will be equal 0. Here in the numerator I had division, so this one of the power 3, this one of the power 3, I can say square root of the power 3 minus 3, which is 0. Then I have 2 of the power, can cancel, and 2 of the power 3 divided by 2 over 6. Then 2 of the power 3, 2 of the power 1, because there is no power, yes, we already know it's 1. 3 minus 1, which is 2. So 2 of the power 2 over 6. 2 of the power 2, which is 4 over 6. And divided by 2 for the both number, we will get 2 of the 2 over 3. And this is the simplest form of this large one. Okay, I hope you understand, and practice more for these types of the questions, and connect with me for any question. Thank you for listening. Thank you for your time, and